Hello again, this is EE545, Embedded Deep Learning, and we start a new subject this week. It is related to the systems engineering perspective for our subject, Embedded Deep Learning. Well, it's a bit, compared to the previous subject, it's a bit longer subject, so I divided it into 2 weeks. Let's start and see how it goes. Okay, well, first, in order to have a systems engineering perspective, we need to understand what systems engineering is, guys. Systems engineering is for undergraduate students and for new graduates like you. It's a kind of complicated concept to understand. Once I had a friend when I was working at a company. He was a good friend of mine, but he was a senior of mine. So when I just started working there, he had been working there for a while, and he's elder than me. And I've started at the systems engineering department actually, and he was working there. He was a senior systems engineer, and he once told me systems engineering is about knowing nothing about everything. Well, it is funny that he says it because he knows a lot of things about a lot of things, but it is like you don't become a specialist in a specific title, but you know a lot of things so that you can have a larger perspective. You can see the big picture on what you're dealing with. And system engineering can apply to many levels. Well, embedded deep learning is a level that you have to apply your systems engineering knowledge. You have to get to know the hardware, the software, the algorithm, and many other stuff. Data structures, whatever. Or this could be a much higher level thing, like going to space. I mean, in United States National Association, NASA, the best system engineers of the world are working because it's a very difficult subject. So the formal definition from the Wikipedia is systems engineering is an interdisciplinary field of engineering and engineering management that focuses on how to design, integrate, and manage complex systems over their life cycles. This is very important because a system has a life cycle. You produce it, you construct a prototype, then you produce it in a serial manner, then you maintain it. All of these require different systems engineering efforts. What we are going to talk about today is just about a very little subject of a very confined field, embedded deep learning. But still, it is very important and you need to get a perspective. Having a perspective in this field will give you a perspective of systems engineering in many other fields. So at its core, systems engineering utilizes system thinking principles to organize this body of knowledge. So there is something called systems thinking principles, how a system works, how we can organize this knowledge, interdisciplinary knowledge in this. That's what you do. The individual outcome of such efforts is the engineered system. So when you finish your systems engineering effort, you have the system engineering design of a system. And it's a combination of components that work in just collective manner, synergy, to collectively perform a user function. And which is in our case to implement deep learning systems in embedded environments. And this will require a level of systems engineering, guys. So guys, how can we see the different aspects of systems engineering in our field, embedded deep learning? I will call them dimensions because they are the different dimensions of building an embedded deep learning system. Well, dimension is like the three-dimensional world's dimensions, like X, Y, Z dimensions. And the reason that we call dimensions is the word dimension, both physically and intuitively or mathematically, is understood to be something orthogonal. Orthogonal dimensions means independent dimensions. In mathematics, two independent dimensions are in the 3D world, X and Y are independent dimensions. When you move along X, your position in Y axis does not change because they are orthogonal. So although not clear as this mathematical definition, there are certain dimensions of systems engineering for embedded deep learning, for our case, which can be considered relatively orthogonal, independent from each other. And I decided, when I was preparing these slides, I decided to put them in three main dimensions: the algorithmic details, the embedded concepts, and the design and usability issues. So because, you might have the perfect hardware for your job, having the perfect condition of computation and power, whatever. You have the best algorithm, okay, but will you be able to design it? Will the engineer who is going to construct it, will he be able to just design it or maintain it? Is the prototype cheap? Or these are the design and usability issues. Well, we won't be interested much about the third dimension. But regarding the first dimension, let's start with it, which is the algorithmic details. Actually, we have done a number of things. We have discussed them so far in this course. The algorithmic dimensions of systems engineering. What was it? What is this dimension is all about is, this dimension deals with how to make a code algorithmically suitable for an embedded solution. Well, okay, you might have a very nice solution working in very nice conditions, but you have an embedded system which doesn't have a floating point operation coprocessor. And your algorithm is fully floating point. And in this case, you do this so-called co-design. You choose the suitable architecture, algorithmic architecture. I'm not talking about the embedded architecture. You choose inception network, or you choose residual networks, or you choose something very simple like an encoder, like an AlexNet. Or you apply a suitable type of quantization, post-training quantization, or you do quantization-aware training because you need to do that. And in the end, when you're doing different levels of quantization, you choose a desired accuracy quantization trade-off. Well, this co-design effort we have been doing so far is actually a systems engineering perspective. And actually, some of you are working, some of you are research assistants in our department, some of you are doing full-time masters, and some of you are working in the field, in the industry. And all of you are using your embedded deep learning or deep learning knowledge to construct algorithms. Well, there is something in common with you. You are trying to make it work for a particular system with given requirements. If you're in the academia, the requirements are different. If you're in the industry, the requirements are a bit harsh because there is something called the customer. Well, what I experienced is, if you're an academic and you get back to industry, because that was what I've done. I was a research assistant at some university. Then I started working at a company when I was 30 years old. I thought that they will refer to me as a researcher. What they referred to me was a systems engineer. Because systems engineers are the researchers of the industry. That's why what you have done so far, thinking that you have been doing research like algorithmic details, inception module, and those things and blah blah, they are considered to be systems engineering stuff in the industry. That's one of the things that I wanted to tell you. Okay, so this is systems engineering, and the first dimension we have studied so far. So the dimensions, I should maybe tell you that, okay, these are the dimensions that I defined. These can include these dimensions. The systems engineering perspective for embedded deep learning can include these dimensions, but they are not limited to it. We could find many other dimensions depending on the requirements of the customer. Someday maybe we're going to build some very science fiction models, and they will have some biological dimension because we'll be using biological cells in some planet, I don't know. Then in that case, there will be a new dimension. But for now, we are confining our dimensions to these. And we have covered so far the algorithmic details. And now, we are going to continue with the embedded concepts. However, the design and usability issues, we won't be covering because it's related to engineering management, and it is not the scope of our course. Okay, let's continue then.